Hello there. Welcome to Astraveo's continuing education series, where for our podcast listeners, we talk about mathematics, the physical sciences, of course the natural world, and our personal favourites, astronomy. Now, you know Joseph and I are all up in and about astronomy. We get super excited about that stuff. So let's get going. Hello, good evening and welcome. Welcome to a new educational series video in which we're going to start a new sort of subtopic. And I'm really looking forward to this one. This is really sort of excites my mind. And it's something I tell my children when I help them with their homework. If I do maths tutoring with some friends in the community, I help some families out here and there. My key line that I always tell them is, mathematics is a game. That's all it is. Because a lot of people are quite sort of worried about mathematics. It makes them anxious. It makes them scared. They don't know if they're going to do the right thing. But as I tell, especially my elder son, Benjamin, I say, yeah, it's just a language. Just like you and I speak French together, the word for house is la maison. Well, in mathematics, there are also rules. It's a language with which you use numbers and shapes and angles and lines to describe what you're talking about. It's just a language. Now, if you know the words of that language and you know the rules, you can speak it. Now, I think mathematics is a game because there's all kinds of fancy stuff you can do in your head to make hard problems very, very simple. And unfortunately, the people who write tests, especially for students, school-age students, they can sometimes make them tricky and the students panic. They think, oh my gosh, that looks so complicated, I won't know how to do it. But if you know the rules of the game, you know the language, the vocabulary, the tenses, and how you put sentences together with mathematics, you can solve them really quite easily. Now, I've written a few down here. Now, if you look at sometimes Facebook or Instagram or TikTok even, you'll see there's a trend at the moment of saying, oh, here's a mathematical question, choose an answer, which one's the right one? Well, sometimes some people get the answer right, but many people don't. And I think part of it is because they're scared of the equation or the question. It looks terribly complicated, but it's there to trick you. They're actually quite easy if you remember your fundamentals. Mathematics is a game. You can play the game up here. So I've written down a couple of examples, and why don't we go through them? Because they're not as bad as you think. Some of them actually look really terrifying, but you'll see they're really easy. As I tell Benjamin, Charlotte, Tennessee, and Morris, my children, mathematics is a game. As long as you can play around with those numbers, you can just juggle them and get the right answer. And let me show you how. Really good fun. All right. This is a really nice one. And I've recently done a video about the laws of indices, and now we can get to use them. We can get to use a couple of those laws in real life, and you'll be able to see how useful those laws are. So here's the first one. Now, again, I think I've just taken this off some Facebook page where they've said, hey, what's the answer to this question? I bet you won't be able to do it. So, mathematics is a game. Now, we know we're going to invoke a cup. This looks quite complicated. 99 to the power 1 times 99 to the power minus 1. Here's the power, these indices we talked about recently. And then here's another index, 0, 9 to the power 0. But also we've got a multiplication here and a minus here. Now, especially here in the US, my children are taught in school the rule of PEMDAS, and it's written PEMDAS. I don't remember learning this in school. I think we were just taught them individually. But this is parentheses, brackets, parentheses, exponent, the law, indices, excuse me. I put exposure, exponent. M is multiplication. D is division. Whoops. A is add. And S is obviously subtract. Now, what this represents is the order in which you do things. So we don't have any parentheses, so we can't do the P of PEMDAS. We do have exponents, though, so we do that next. There's a subtraction. We do addition and subtraction last. We have an exponent. We have to do that before additional subtraction. Let's do it. 99 to the power 1 is just 99. Anything to the power 1 is itself. 2 to the power 1 is 2. 10 to the power 1 is 2. A million to the power 1 is a million. So 99 to the power 1 is 99. Now, if you remember from our law of indices episode, Anything to the minus is 1 over. Now, we've got a 1, so it's just itself. So this is multiplied by 1 over 99. So we do that part first, and then we do the subtraction. Well, again, if you remember from the law of indices episode, anything to the power 0 is 1. So we just subtract 1. Okay? 9 to the power 0 is 1. Well, let's do this part first. We're actually solving, so we need equal signs. 99 times 1 is 99, divided by 99 minus 1. Well, 99 divided by 99 is 1. You're left with 1 minus 1, which of course is 0. So on paper, when you first look at this, and like I said, I think I saw it on Facebook as one of these things of like, if you can answer this mathematical question, you're a genius. It does look complicated, but as long as you remember your fundamentals, the law of indices, that's what these two are, to the power 1, to the power negative 1, and to the power 0. And then PEMDAS, which is the order in which you do mathematical operations, numbers in parentheses first, then do the exponents, multiplication, division, addition, then subtraction, in that order. Well, we did exponents first. We dealt with 99, and 99 to the minus 1 is 1 over 99, because the minus is part of the index. And then we subtract. That's the very last thing we do, but that's okay. And that 9 to the power 0 is 1. That's one of our fundamental laws of indices. 99 divided by 99 is 1. Subtract 1 is 0. So the answer to this one is 0. Not too bad at all. But again, it's a game. All you have to do is remember your law of indices. So what looked like a very, very complicated statement to begin with is actually quite simple. Okay, and I think you'll find all of these things you see on Instagram and Facebook and TikTok, where they say, oh, if you can answer this, you're a genius, or, you know, if you answer this, click like and I'll send you a free bicycle, or whatever the heck they do. Obviously, they're trying to scam you on that one. But the things that these mathematical questions the people put on there to engage you, to get clicks and likes, they're not that bad if you remember your fundamentals. So let's do the next one. Mathematics is a game. As I said, my eldest son, Benjamin, will remember this because I used to say to him, what's mathematics? And he'd say, oh, I hate mathematics. It's difficult. Or why do they give us such hard questions? And I'd remind him, it's a game. Just play with the numbers in your head. Remember your fundamentals. And he got pretty good at it, actually. Okay, well, this next one, again, on paper looks terribly difficult. We have the square root of x squared minus 44 equals 10. Now, again, on paper, that's starting to look difficult. You've got a square root, you've got an x squared, you've got an indices here, you've got a sort of interesting power. This is one of the laws of indices here. And then you've just got a simple number. Well, anytime I see a square root in a simple equation, of course, if it's a more complicated equation, you have to be a bit more careful. But if I just see a square root like this, in my head, I'm thinking, ooh, we could square that and just get rid of the square root. And I'll show you how. Really, don't forget the law of indices. Anything with a root gives you an index. So that index, if you remember from the episodes with law of indices, is a half. Anything to the power of half gives you a square root. That should have been more correctly written there with a fancy 2, so we know it's a square root. If there's never a number there, you can assume it's a square root, because very rarely actually in mathematics or economics or architecture will somebody, if it's a third root or a fourth root or a fifth root, they'll write the number 3, 4, 5. If there's no number, you can assume it's a square root. Okay, that equals 10. Well, the best way to get rid of that is to times it by itself. And if you remember from the law of indices episode, x to the m times x to the n is x to the m plus n. So if we times this by itself, this whole thing would be x. This is the m. But if it's times by itself, it's also the n. So a half plus a half would give you 1. Anything to the power 1 is itself. So I'm going to square this, times it by itself, and that just gives you x squared minus 44. Well, if you remember some of my earlier episodes of the Astraveo educational series, so whatever you do with an equation on one side, you have to do to the other. So if we times this by itself, we have to times this number by itself. And we know, of course, 10 times 10 is 100. So we have to be really careful you don't forget that. You can't just multiply this by itself and say, ta-da, I'm done. Well, now our equation doesn't look so hard. So what we're going to do is we are going to add 44 to both sides. And negative 44 plus 44 is 0. It just goes away. So you're left with x squared equals 100 plus 144 is 144. And we can take the square root. Square root of anything squared is just itself. So you're left with x equals plus or minus 10. Oh, 10. Oh my gosh, I'm all over the place tonight. What the heck? 12. I apologize. 12 times 12 is 144. We need the plus or minus. And I realize I say this every time we do an educational video. A negative number times a negative number is a positive. We started with positive 144. So we need a plus or minus. It could have been a minus 12. So what we did was we started with this quite difficult equation. On paper, it didn't look very pretty at all. But we knew from law of indices that if we squared it times it by itself, that square root would go away and it would equal the power of 1. Don't forget, whatever you do to one side of the equation, you have to do to the other. We times this by itself, we have to times the 10 by itself. And then it's just a little bit of simple mathematics. So we remembered our fundamentals. Again, what looked like a fairly complicated equation turned out to be fairly simple. Now this next one, I love, because it's just a fundamental mathematics question. Mathematics is a game. Again, Charlotte, Tennessee, even Bo Morris. Bo Morris is a wee bit younger. He might not remember this as much. But this is mathematics being a game. This letter C. What is 12 squared minus 12 divided by 3 times 4? Now, again, I did get this one from one of these Facebook posts. I think I saw it the other day. I was in bed and I happened to see it scroll up on. I said, "Oh, that's interesting. I'll maybe think about that for my educational series." Now, the difficult part about this is you're thinking, "Oh, where do I start? It's a bit complicated." It isn't really. I'm not even sure you need to think of PEMDAS in this part of the equation. I think you just need to think of fundamentals. Now, there are several ways of doing this. We could just do it the brute force way. 12 times 12 is 144 minus 12 divided by 3 times 4 is just 12. Well, 144 minus 12 is 132. Divide by 12 equals 11. That one's not that difficult at all. You really just had to multiply out and you had to square the 12 and that was it. So this one is indeed 11. Now, because I think mathematics is a game, I'm never really satisfied with just one answer. I like playing around. So here's what I did for this one. Given there's only one number on the bottom, the denominator, you can split this up. It's essentially a fraction. You end up with 12 squared minus 12, whoops, didn't do my curly 2 very nicely there, divided by 12. Well, because you've only got one denominator, you can split it up. You can have 12 squared divided by 12 minus 12 divided by 12. We have a common denominator. It's only one number. So these two expressions are identical. Well, 12 squared divided by 12 is just 12. Because, again, there's an index here. That's actually 12 to the power 1. And we know from our law of indices, again, with subtraction, x to the m divided by x to the n is x to the m minus n. We did that in a previous episode. Well, m in this case is 2. N is 1. 2 minus 1 is 1. So 12 squared, 12 to the power 2 divided by 12 to the power 1 is just 12. Now we know that because 12 squared is 144, divide by 12, 12 times 12 divided by 12 is 12. So this number here goes to 12. Well, 12 divided by 12 is just 1. You get 12 minus 1, 11. So two different ways of doing it. But again, not particularly complicated. But yet, whoops, here it is. When you first see it, you're thinking, oh, that could be complicated. I see a multiplication, a minus sign, I see a square. Where do I start? Fundamentals of mathematics. Mathematics is a game. I'm always going to come back to that expression because they do this especially in middle school, high school, and Tennessee and Bill Morris are starting to see it in elementary school. Sometimes these question writers, they sort of try to trip students up by giving them what on at first glance looks difficult, but it's actually not, as long as you know the rules and the fundamentals. It's a game, it's a language. Just like if you speak English or French or Chinese or Arabic, as long as you know the vocabulary and you know the verb structure, you can speak the language. In mathematics, if you know the symbols and how they're put together, you can speak the language of mathematics. Now this last one is a juicy one. It's actually, again, sort of follows on from my Law of Indices educational series video I did a wee while ago, or not too long ago. It looks terribly complicated. Now it's really tempting here just to think, oh, 2 to the 7 minus 2 to the 6 is 2. That's not the right answer. And part of the problem of that is it's not a divide by. That would be okay if it was a divide by, but it's not. It's a minus. This is some big number minus another big number, but it's slightly smaller, and their difference is not 2. So at first glance, you're thinking, ooh, that's tough. Mathematics is a game. That's all it is. As long as you can juggle a few numbers in the air, you'll get this. And here's how. We're going to leave the square root alone at the moment, not even going to touch it. Again, if there's no number, it's a square, it's a number 2, but I'll put it in just to be formal. Now what we can do is we can do something cool called factorization. Here, there's a 2 to the power 6. There's also a 2 to the power 6 in the number 2 to the 7. You just can't see it. It's 2 to the 6 times 2. So what we're going to do is we're going to pull out the 2 to the power 6 because it's common to both of these. Open up some brackets, some parentheses. As I just said, 2 to the power 7 is just twice 2 to the power 6. So you can put the number 2 here. 2 times 2 to the 6 is 2 to the 7. There's a minus sign. 2 to the 6 goes into 2 to the 6 once. So you can put the number 1. Okay. Now, we have, keep the square root, 2 to the power 6. 2 times 1 is 1. 2 to the power 6 times 1 is 2 to the power 6. So now we have a much simpler expression, 2 to the power 6. Now, I happen to know that the square root of 2 to the power 6 is 2 to the power 3. But we should be able to prove that to ourselves. 2 to the power 3, by the way, is 2 times 2 times 2, which is 8. Okay, so that number, whoops, this one here is 8. What does look terribly difficult is actually not bad at all. Now, how did I know the square root of 2 to the power 6 is 2 to the power 3? Mathematics is a game. We know this because, again, remember our fundamentals. This is actually going to turn out to be a fraction. So we're going to use our law of indices from a previous episode. A square root is anything to the power 1/2. Okay? So we have 2 to the power 6, all to the power 1/2. The half is the square root. Okay? 2 to the power 6 to the half. Now, if you remember from your law of indices, multiplication, x to the m times x to the n is x to the m times, n. So this is 2 to the power 6 times 1/2, which I'll move it down here, which is 2 to the power, 6 times 1 is 6, divided by 2, is 2 to the power 3. So while I happen to know that number, because I know my mathematics, I know my fundamentals, I can play the game in my head. I'm just juggling numbers. I'm not being a genius. I'm not being an Euler or an Einstein or a Niels Bohr or one of these super famous mathematicians. I'm just juggling very simple mathematics, my fundamentals. That's all I'm doing. So I happen to know that the square root is to the power 1/2. 6 times a half has to follow the law of indices of any number, any indices times each other, the same base, is m times n. Actually, I have not got that correct. That's multiplication. These are raised power. I'm glad you caught me out there because I wrote that incorrectly. It's x to the n to the raised power of n. That was our third or fourth law of indices when we did that episode. I actually made a mistake there, so I'm glad we did that. We did a check. That's why we always check. So I actually did that incorrectly. It's x to the m raised to the power of n. I did make a mistake. Glad we caught it. 6 times a half. 6 times a half is 6 over 2. 6 divided by 2 is 3. 2 to the power 3, which is just 2 times 2 times 2, which equals 4 times 2, which is 8, which is what we have. So we started out with what we thought were quite complicated sort of riddles, mathematical questions, and it wasn't really that difficult after all. All we had to do was remember our fundamentals. A little bit of law of indices here. A little bit of law of indices. I'm remembering to square something squared. Square root squared is just itself. A really, really nice one here. A little bit of law of indices or some simple fractions. And we've talked about fractions before. And this one, which does look complicated on paper, let me get rid of my PEMDAS here, does look complicated on paper, but as long as we know that we can factorize the 2 to the 6, because 2 to the 6 is inside 2 to the 7, it's just 2 times 2 to the 6, we could factorize this and then use a little bit of law of indices here to realize that this was just the square root of 2 to the power 6. So some really nice mathematics there. So I think I'm going to continue this series of Mathematics is Just a Game because I see these types of questions all over Facebook all the time. And I think we can have a bit of fun with it. And I'd love you to get used to the idea of juggling numbers in your head, thinking about mathematical fundamentals, and seeing something complicated like this and thinking, yeah, I can get that. That's not difficult. Give me 5 seconds. Give me a few seconds. I'll think it through. I won't panic. Bang, we're in business. Okay, thank you for watching.